Now, as I said, we have just like mainly two concepts which are very interesting in this lecture. The first one, I think we discussed how to convert your networks to fully convolutional. That has a lot of applications. The second aspect is softmax activation. Okay, so pay close attention to this. This is a very, very interesting concept. Now, the idea here is whatever prediction your network is making, we actually want them to be a little interpretable. For example, like the earlier scenario I shared, like let's say if you're using a railway activation, so it's very hard to compare like values of 10 versus 1000 or 10 versus 100,000. Okay. So what softmax does is, again, it's activation function, and it tries to turn your network predictions into probabilities. Okay, and it's very powerful actually. So the way it does that, it will take whatever network predictions you have, and one thing it will do is it will scale it between 0 and 1. So that's like the basic rule, right? Because your probabilities cannot be negative and your probabilities cannot be greater than 1. The maximum probability you can have is 1. So what it will do is it will try to normalize the values between 0 and 1. And the way it does is it's not just scaling. Of course, you can just put a sigmoid and it will give you 0 and 1. What it does is it tries to take into account like different magnitudes of the classes you have. For example, if you have 3 different classes, it will look at all the 3 classes at once. And that's the difference between sigmoid. Sigmoid will not be able to do that. So what sigmoid will do is it will look at 3.2, and then maybe you will have some kind of upper threshold, right? And then it will directly convert this to like 0 and 1 without looking at this 5.1. Okay, but softmax, when it's trying to convert this to probability, it will also look at this particular value. Now let's see how that's done. And this is like a very simple softmax activation function. If you look carefully, it's a very simple function. What it's trying to do is it is first trying to compute the exponent of all the predictions. So E is for exponent, and Sk is like for the prediction of the network for kth class. All right. And in the denominator, you have summation. Okay, so this is summation over all the classes. And again, what you are summing up the exponent of all the predictions. Okay, so then the basic step should be, what you need is you need exponent of all the predictions, right? So let's do that. If these 3 are your network predictions, and this was a cat, but your network predicts like 3.2, 5.1, negative 1.7, I mean, how can I interpret this? I mean, I don't know. This is a negative value, so I can say, okay, frog is not present. This is like 5.1, seems like positive, so car could be present, right? But then cat is also 3.2. So of course, the network is making error. It's kind of because this is the maximum one, and the network is saying this is a car. But then there is no way of telling that, like how good the network is doing, right? I mean, I can't tell whether 3.2 is pretty bad or it's like maybe pretty close. So that's what like softmax will help in solving for us. The first step, you compute the exponent because we need that. Okay, so you just compute the exponent values. All right. Second step is you need like summation of all this for the denominator. Right? So you can just add these values, which is fine. It will give you something like maybe 190 or out, that number, right? And then what you do is once you have that number, for each class, whatever exponent you have, you just divide with that number. So in this case, it will be 24 over that 190, and that will give you 0.13. And again, this will be 164 over 190, going to give you this, and this is going to be 18 over that number, so pretty close to 0. And these are actual probabilities. Okay, so there are like some interesting properties here. You can easily say that, okay, the confidence score of this prediction for this image being car is 87%, and that I can interpret. Okay, 87%, that seems like a very high number. And the probability of this image of being for a cat is just 13%, and which I can easily interpret. 13% is pretty bad, right? So I have like some sense of how good the network is doing. And this is completely zero. Negative was not, I mean, I can't say like how good or bad this is, but zero I know. So frog is definitely not present. Okay, so that's like one thing. The other thing is these are probabilities. So what should happen if you sum up all these? It should give you exactly one. So you can do that. It's equal to one, right? And that's because like the equation you're using. And that's how probability works, because then you can't have probability of one, like if you sum all of those and then everything is normalized. Okay, so that I think is a very interesting concept. And if you have to solve like a single level classification and you have a lot of classes, you should always use softmax, okay, to train your network. This should be the final layer in your network always. It will help you like in training your network much better. And also it will give you some kind of interpretability. Now, again, I mean, we have good things, but again, nothing is like a pure gold, right? So what if we have multi-labels? Then this is not going to work. Because if you have multiple labels, then first of all, your sum of probabilities for like all the classes cannot be one, because you can have both cat and car present in the same image. And if that's the case, then this will have probability one, this will have probability one, this might be zero. So that will sum up to two, right? And that's not right. And sadly, that's the case. If you have multi-label classification problem, you should never use softmax. It won't work. And the simple trick is use sigmoid activation. Okay. And what sigmoid will do is it will independently normalize your network predictions between 0 and 1. And which is fine, because for multi-level, we don't care about like normalizing across classes. And the reason is multiple classes can be active at the same time. So still we'll be able to interpret those values pretty well.